In the beginning, there was information. A presentation written and narrated by Chuck Missler and Dr. Stephen Meyer.
We have with us today Dr. Steve Meyer, the director of the Center of Renewal of Science and Culture with the Discovery Institute. And that's the Discovery Institute in Seattle.
That's
is that right?
correct, yeah.
Dr. Meyer. And he's associate professor of philosophy at Whitworth College. He does doctoral work in history and philosophy of science at Cambridge University in England. His dissertation was on the origin of life, or the whole life question in biology. Is that right?
That's correct.
Yeah. Well, nice to have you with us.
It's great to be here, Chuck.
We obviously, this whole issue of evolution or Darwinism, although the terms are used very imprecisely by most laymen, everyone is quite conscious of the fact that on the one hand, it's the underlying conviction of the culture, not just in science, but our whole political system, the field of psychology. You can just go on and on. It's just imbued our entire culture on the one hand. And on the other hand, and it's also become, of course, a major tension, problem, source of confusion for the Christian for many reasons. Mm-hmm. And some of them quite clear and some of them perhaps more just instinctive. And what's interesting is the average person on the street takes for granted that scientists, that's in quotes, believe in evolution. And it's the Christians that have this crazy idea of creation from the Bible and so forth. And what's really refreshing is that this whole debate is emerging, has blown open in the scientific world and is also becoming a very common conversation even among laymen. Mm-hmm. And I appreciate you being with us and shedding some light on this whole issue of the origin of life. So let me just throw it at you to give us a summary of how you see the present situation in our culture.
Well, what you say is exactly correct. We sometimes in the world of philosophy talk about a worldview, and the worldview that's dominated at least the elite institutions in our culture, the universities, the media, the law schools, is a worldview that's sometimes called materialism or scientific naturalism. And it's the idea that nature and matter and energy are all that really exists. So there is no God, there's no consciousness or free will. And if you take that starting point, then that has consequences for every area of life. It changes our view of human nature, our view of psychology, our view of the law. And the thing that many people don't recognize is that worldview has really come from science. In the science of the late 19th century, which tried to explain the origin of the universe and life and complex life and human consciousness in materialistic terms. That science has underwritten a view that makes it impossible for us to believe that we're made in the image of God and the kinds of traditional views of moral responsibility that we assume in our culture and the legal system and other places.
Well, much of this, of course, is attributed to or was birthed, in a sense, by Darwin and what followed. I gather that you might just recount for us briefly the insights that have started to cast doubts about the Darwinian view.
Well, the key thing really began I would say in the 1950s and 60s as people began to open up the cell. And the essence of the Darwinian world picture, if you want to call it that, is that complex things come from very simple things. And if you start with a very simple cell, you can, through the process of natural selection acting on random variation, produce much more complex things if you give the process enough time. So you can start with very simple one-celled things, and you can eventually produce complex creatures like ourselves. What began to really undermine that whole picture of life was the recognition that the very simplest thing was enormously complex, that the simple cell wasn't simple at all. In the 19th century, one of my favorite quotes from the 19th century scientist who got it wrong was Ernst Haeckel said that the cell was a simple homogeneous globule of plasm. It was like Jell-O. And as long as you believe that the basis of life was this simple protoplasmic Jell-O, it was easy to imagine that it had climbed out of the slime, that some kind of very simple chemical processes could produce it. But starting in the 1950s with the elucidation of the structure of DNA and with the recognition that the cell is an information processing system and that you don't have just matter and energy in the cell, you have information, this third fundamental entity, very simple view of the cell has evaporated very quickly. And now explaining the origin of the simplest thing turns out to be very complex and something very hard to do.
Now, you've introduced another dimension to this that I'd like to underscore as we go along here. Most of us that have, in our educational context, understand that there is obviously the field of chemistry and physics and biology, what we might consider the classical sciences. And many people don't realize that there's another field of science that in itself is probably, as a subject of its own, a relatively new science as sciences go, and that's the information sciences. And I think for a lot of this really emerged from the Second World War on, and through Shannon and Wiener and all that rest, and the advent of computers and advanced communication theory and so forth. That the whole field of information itself is distinctive, just as mathematics is distinctive from physics as such, as a tool, as a set of definitions, and accompanying insights. And I want to emphasize this because Steve has a information science background. Even before his academic career, he was involved in signal processing and so forth. So he has a natural background and instinct in the information sciences, something that is surprisingly lacking, even our technical culture. I'm intrigued, as I've gone through my career, how most engineers have been taught deterministically. Those few engineers that have a stochastic background, that understand statistics, understand probabilities, are relatively modest, and yet they're the ones those that have skills in that area typically have them because of an awareness or an involvement in communications and in places where signal processing is relevant. And that's turning out in today's world to be paramount, because the embarrassment in physics is a thing called quantum physics. They suddenly discovered that even causality is questionable. And I don't want to start on the whole that whole thing, except to point out that there's a major upheaval, even in our most firm, our hardest, as they say, the hard sciences of physics is an upheaval because of the strange discoveries of quantum physics. And all of this leads us to a very probabilistic model of almost anything. And that's exactly what we're going to be hitting head on here.
Well, and one of the things that happened in biology in the 1950s, the great discoveries were made by biologists who came into biology from physics and from the information sciences. Francis Crick was a cryptographer during World War II, and there's a fascinating passage in Horace Judson's wonderful History of Molecular Biology where he explains how Crick liberated the DNA, the concept of DNA that the scientists had before, from the strictures of a strict materialistic mindset, and by introducing the notion of DNA as an information carrier, that it wasn't just a chemical, it was a chemical that coded something, that it carried an intangible, it carried information. And once that breakthrough was made, that insight was made, that opened up the whole of the molecular biological revolution, as it's been called. That's what enabled people to start to see what was really going on inside life.
We're getting ahead of ourselves a little bit in this discussion, because even before Crick and all of that, this whole premise that somehow there was a prebiotic soup out of which lightning or ultraviolet rays or whatever somehow caused amino acids to happen accidentally. The Miller experiment probably deserves some comment. You might explain that.
Sure.
Miller experiment.
Well, it might be helpful to make a distinction for your listeners. The theory of biological evolution, Darwinian evolution, is the attempt to explain complex life from very simple life. That approach was extended by people who were called chemical evolutionary theorists, who wanted to explain the origin of simple life from simpler chemicals. And the first scientist to come up with what appeared to be a credible and comprehensive theory was a Russian named Oparin, and he had a very elaborate explanation as to how chemicals could have been transformed and made more and more complex, and finally enclosed in the form of a cell, and eventually became primitive living things. One of the steps along the way was the step that got you from very simple chemicals to amino acids, which are the building blocks of protein. And there was a scientist in the 1950s named Stanley Miller who attempted to simulate what he thought might have the processes on the early Earth would have been like. And he set them up in a spark discharge chamber, put some gases and gave it a spark.
Methane, ammonia,
hydrogen. They were called reducing gases. They were ready to very reactive, and he sparked them, and they reacted, and he got 2 or 3 of the proteinaceous amino acids in his collection vessel at the bottom of his experiment. And this was heralded as a great breakthrough by the media, and it's
even
still
today people point to that somehow proved everything.
It's still in high school textbooks. books. And now, of course, even Miller himself and pretty much everyone who works on the origin of life recognizes that this experiment has virtually no relevance to the actual processes that would have given rise to life, in part because the gases that Miller chose we now think were not even present on the early Earth.
And worse than that, as I recall, the presence of oxygen was assumed not to be there for various reasons. That's also proven to be wrong, that oxygen predated the plant life, et cetera.
Exactly. We think there was a certain amount of oxygen from volcanic outgassing and other processes. With that, even a small amount of oxygen has a quenching effect on the important biochemical reactions that would move in a life-significant direction. So this is the significance of Miller's experiment at the time was that it was thought to be a simulation of what the processes on the early Earth would have been like. Once you take away the idea that it's simulating anything, then it's just an experiment.
Gotcha. But it comes up so often, I wanted you to touch on that. So, but the real nail in the coffin is really microbiology in the sense of Crick and the DNA and the whole coding thing, which is really what you want to focus on here.
Well, if you think about those amino acids, they're like I use an example of snap lock blocks that my kids play with. The amino acids are just building blocks. They have to be arranged in very specific one-dimensional linear arrays in order to form proteins. So if just having the building blocks but not getting them to link together, and especially getting them to link together in the right sequence, gives you nothing. So you really need something more than just the stuff. It's got to be arranged in the right way. And those arrangements we know in the cell are actually dictated by the informational code that's in DNA. The DNA provides the information that tells the cell how to build the proteins that we need to stay alive.
But isn't there an argument advanced that these things could have just happened by their intrinsic physical or chemical properties? I'd like you to talk on that whole issue, because that's something that's so fundamental. If we really understand that, the whole thing becomes very, very clear.
Well, initially the idea was that that you could build these complex molecules just by chance alone, and then people started in the 60s running the numbers on it. It was the field of combinatorics, that as you looked at all the combinatorially possible ways of arranging those different amino acids, or the different bases they're called on DNA. It was a vast number of possibilities, only very, very, very few of which could possibly yield a functional DNA molecule or protein molecule. And so the chance hypothesis kind of went by the boards. And one of the things that replaced it late in the 60s was the idea that it wasn't chance, it was the other end of a continuum. It was necessity. It was something that had to happen. It wasn't improbable. It was very probable, like a law of nature. And the problem with that is that if you think carefully, what the scientists are trying to explain is the information on DNA. It's stored in literally a 4-letter alphabetic code. And if you talk about information arising from physical and chemical necessity, you're really talking nonsense. It's a contradiction in terms. The way to think of it might be to think of a crystal of salt. If you have you put sodium and chlorine together, you put the ions together in an aqueous solution, the Na and the Cl will stick together. It's a chemical attraction, and you'll get a repeating pattern: NaCl, NaCl, NaCl over and over again. But that's a mantra. It's not a message. It's something it repeats over and over again. Information scientists call that redundancy. There's no new information after you've seen the first NaCl. And so physical chemical processes or physical chemical laws, by their very nature, are describing or producing regular patterns that repeat over and over and over again. So the attempt to explain information, which is intrinsically unpredictable and aperiodic and complex, is the word we use in the information sciences, by reference to those laws is a non-starter. It's an incoherent. It's a self-contradictory idea. Laws, by definition, produce repeating patterns. Information, by definition, has an element of unpredictability and complexity in it.
Yeah, I guess the good example that pops into my mind as one of my favorite examples is the Old North Church and the famous poem about Paul Revere. And he was watching the Old North Church. It was at a prearranged time. The lanterns in the Old North Church was if the British were coming by land, one if by land, two if by sea. And so here we have a binary, a coded binary message. The first lantern gives you no information because you knew there was going to be one. And all that proved was that the guy didn't fall off his ladder or whatever, that all the information was carried in one bit. The second lantern told you how the British were coming, and thus triggered, of course, the whole military situation for the revolution. But what's interesting about that is that if the British had 100 Cray supercomputers, they could not have solved that little simple code because it entirely depends on prearrangement, context. And there's nothing, there's no physical attributes of the lanterns between one another. If there had been, it would be meaningless.
Right.
The fact that that guy could hang two lanterns rather than one if he wanted to, with no physical detriment, so to speak, is part of the requirement for the alphabet. And I guess that's what you do so colorfully with your little magnetic letters, is to point out that if there's an affinity, if A's can't reside next to B's, which can't reside next to C's for some electromechanical reason, then they'd fail to function as members of an alphabet, because you need, as a writer, I guess another way to put it is, if you were printing a book, the letters on the page better have no electrochemical interaction with each other. They just have to stick to the page.
Right. Imagine if you had a situation where every time you got an A, you had to get a T, and every time you got a T, you had to get an A, and every time you got an A, you had to get another T. Then you'd get AT, 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 and that'd be a very uninteresting message. It limits the bandwidth, as you put it.
And the key point is that if it's predictable, it's carrying no information.
Exactly.
Yeah, right.
So,
Gotcha.
another maybe a real intuitive way to think of it is, that the information that's encoded in your morning newspaper headline is not the result of the physical and chemical processes or properties of the ink and the paper. The information is coming from outside the physics and chemistry, from the mind that arranged the letters. It's not the arrangement is not dictated by the ink sticking to the paper. The arrangement is determined by the writer. And the example that you mentioned I use in my talk was my kids use magnetic letters to spell messages on the refrigerator, and the magnetic force explains why the letters stick to the refrigerator, but the physical chemical magnetic force does not explain how the letters are sequenced. And you have precisely the same thing in the DNA, that the physics and chemistry explains why the molecule holds together, but it doesn't explain the origin of the sequencing that is in fact the information.
And if those letters, set aside the magnetic character, if those letters were just letters like alphabet soup or something, and you found them spilled on the floor in random order, they would be there, you'd attribute that to random order. If you looked down the floor and found the letters spelling out a sentence, you would reject the hypothesis that was just spilled letters. You would assume that someone came along and nudged them into, that Jane has gone to the store.
Exactly.
Or something like that.
Exactly.
This is really, this gets into, maybe this is a good place to sort of introduce the Dembski argument, the whole, what we mean by design inference. Because what really intrigued me about his writings is that he maps a spectrum from things that are highly improbable all the way to things that are very probable, with obviously various probabilities in between. Something that's highly unlikely to happen approaches zero probability. Things that have a high certainty of happening are close to unity, and everything else in between. In science, the earliest sciences were ones that could draw inferences at the highly probable end. And then when somebody dropped an apple, it almost always fell to the earth. Mm-hmm. And that became a law, because the probability of letting go of that apple was essentially certain that it would fall. We call it the law of gravity. And extending that a little bit, the whole field of science was one of rejecting chance as a rival hypothesis in trying to establish something that would qualify as a law. Now, as we move on that scale towards the middle, towards things that sometimes happen, sometimes don't, we're suddenly in the domain we glibly call chance, where things are subject to what we call mathematically random variables. And part of the game in life is to discern patterns in that. That's how we discern markets. That's how we make forecasts. That's how we control inventory. That's how we do most of the processes that we encounter in real life are in this middle area, which have some predictability. That's why we succeed or fail on something, and yet are also characterized by various levels of probability. There's a whole field of study called design of experiments, in which we try to master our ability to discern somewhat hidden cross currents in our culture. As we move to the extreme end of the scale of highly improbable events, we start getting into an area that is really the subject of our discussion here. A part of that field, as you get to events that are highly improbable, one of the sciences that deals with that is cryptography. When you intercept a message, which seems to be a whole bunch of apparently random letters, But by using skill and trial and error and all kinds of statistical tools, you begin to discern that, gee, this is really hidden in this message is a meaningful sentence. Mm-hmm. We decrypt the message by skills that are well developed and probably represent the real cutting edge of our technology in the information sciences. That's what the National Security Agency is all about, and so forth. Well, this is what's interesting is that I suspect it's fair to say that in almost every field of science, when you find something that's assembled, some complexity that's highly improbable of happening by accident, that we attribute that to design, except in one field of science. And that's the science of biology. So I get the impression, correct me if I'm being unfair here, but I do get the impression that the entropy laws are accepted in almost every field of science, except entropy in the information sense, is except in the field of biology. They seem to have defined that out of their purview.
Well, a minute ago you gave the example of a set of letters on the floor that spelled out a message. Jane has gone to the store, or whatever it was. And what that illustrates is that uniformly in our experience, universally in our experience, we recognize high specified information content. High information content as an indicator of mind, as an indicator of intelligence. But in biology, there's been an exemption of that regularity. The regularity is that if you have a high information content, you don't know and then it was caused by intelligence. And we see all kinds of examples of that. If we're looking at hieroglyphic inscriptions in archaeology, then we infer that there was a scribe behind them. If we look at computer code, we think there was a programmer. But when we see the information in the DNA molecule, there are people who want to say, well, no, that would be unscientific to infer design. In this case, we need to keep looking for a naturalistic explanation.
When they make that statement on their part, they are practicing religion, aren't they?
Well, they're practicing a form of, I think, metaphysical bias.
What I'm saying is they're really indulging the very behavior that they're accusing us of. Right.
In some rhetorical contexts, we've called it Darwinian fundamentalism. It has a proper name. It's called methodological naturalism. That means if you're a scientist, you're duty bound to limit yourself to naturalistic explanations. But our experience shows that there are some things.
That's tragic right there, because that's a confession that the goal of science is not truth.
Exactly.
Goal of science is to find a explanation within a set of boundary conditions that are self-defined.
When part of what we're doing in the design, this movement of scientists who are working on design, is we're not only making the case, the evidential case that there is evidence of design in biology, but we're also challenging those rules of science that prohibit people from making the most natural and rational inference from the evidence. So one of the things we say we're advocating is a more open philosophy of science that allows scientists to seek the best explanation, not just the best naturalistic explanation.
In fact, that's probably the really exciting fresh wind that's blowing across our intellectual campuses and so forth, is that it's not a question of Darwinism versus creation. That is emotionally charging it. What it really is asking the question: is Darwinism good science? And what's really exciting about some of the debates that are occurring is that it is the evolutionist side that gets emotional, that doesn't know how to deal with the adverse argument, which is not biblical necessarily, not creation necessarily, simply arguing for design.
We've seen a lot of that really personal attack and caricaturing motivations and that sort of thing. It seems to go with the territory, but of course it makes it more exciting.
Tell me more about the movements here. Give me some specifics. The scientists that are, so to speak, leaving the evolutionists.
Well, one really dramatic example of that, there's a lot of younger scientists and folk that have come out of really top graduate programs who somehow decided that they just weren't buying it anymore. The standard Darwinian naturalistic explanation for everything. And but a very key intellectual conversion occurred in the late 70s with a man named Dean Kenyon. He was a leading chemical evolutionary theorist. He'd written a book called Biochemical Predestination, which is still one of the best-selling college-level texts on the origin of life. And he had, to that point, devoted his life to explaining the origin of life from simpler chemistry. And he came straight up ahead or against this information problem. And some students actually challenged him with some ideas that he really was not prepared to deal with, and through some soul searching came to the view that the cell really did bear evidence of actual intelligent design. He later had a religious conversion experience. He's now a convinced Christian, but his first conversion was a scientific one, and it was based on evidence. And a few years later, there were three authors, Charles Thaxton, Walter Bradley, and Roger Olson, who wrote a book called The Mystery of Life's Origin, and they didn't yet know of Kenyon's change of mind, and they still regarded him as the leading person on the other side of the issue. They were writing a book that was defending the idea of design and was showing that there were real problems with all the naturalistic chemical evolutionary theories. And so they sent their manuscript to Kenyon and asked him for his response as, kind of a gentleman's approach here. Give us your best criticism. Kenyon called them out to his university. He was at San Francisco State, and asked if one would come out to discuss the book and the manuscript with him. And he started by saying that he actually liked it very much, and he gave them a few kind of niggly criticisms, but then, went on to say that he'd effectively in the ensuing years come to the same position that they had. And so Thaxton asked him if he would write the foreword for the book. And so in 1984, this was really a seminal event in the developing interest in design. A major book came out, authored by three very well-credentialed scientists, with a foreword from a previous intellectual opponent of the position that they were advocating. So from there, then things have grown very rapidly. And just at the Discovery Institute alone, we have some 40 scientists and philosophers of science who are working on these kinds of issues. From this perspective, advocating design.
That's exciting. That's why I'm so pleased that you could join us here. We talked a little bit earlier about Dembski and the whole idea of the design inference.
Right.
We've touched on his, but there's another person that is really blazing a trail. Or has blazed a trail, is Michael Behe, and he has introduced this concept of irreducible complexity, which is a way of expressing something that, in a sense, I think Bishop Paley kicked off way back before the turn of the century, but Behe did it so eloquently, so specifically, and then with some examples. If you want to touch on that a little?
Well, Behe's argument is that the cell is enormously complex, but it's complex in a very particular way, and that is that there are often that in every system and subsystem within the cell you find. Let's back up. Behe's argument trades on the complexity of the cell, and what he shows is that there are systems within the cell that have a feature he calls irreducible complexity, and that is simply the idea that these systems require multiple parts functioning in close coordination all at once in order for there to be function at all. So in my talk, I showed a picture of the bacterial flagellum, which is a little motor on the back of a very simple cell.
Before you get into that, I think it'd help our listeners to use the mousetrap example.
Oh, yeah, right.
Because he makes such we've all gone to the store and bought one of these little old-fashioned wooden mousetraps, a little block of wood, a spring, a hammer, or a thing that actually crushes the mouse eventually, and a little trigger mechanism to release the hammer. And obviously, people have for a long time tried to simplify that, and you can't. In other words, it takes a certain minimum number of parts put together in a specific way to make the mousetrap work. And so that's perhaps a very simple household example of what Behe would call irreducible complexity.
And he has a funny homespun way of putting the point. He says if you remove one of the parts, if you remove the lever, for example, or the catch, you don't catch 4/5 as many mice. You have a broken mousetrap. And that's another way of saying it's irreducibly complex. You take away.
Or mathematicians say it's a nonlinearity. In other words, there's a point at which there's a major discontinuity in design.
Right.
And I think what he carries that forward then, that anybody in our audience that's been part of a design team, any systems engineer out there would understand that if you've got a system consisting of subsystems and the survival of the system requires the performance of all the subsystems, it's very, very clear that the design of the subsystems has to be very skillfully coordinated. If the survival of the total system depends on each of the subsystems working, you've got a situation that has to be designed, can't happen randomly. In fact, it's got to be very skillful design in the reality. So those concepts it kind of amuses me because if you get people off the street, practical technician type people, they understand that quite a bit. When you get people with the PhDs behind their name, and I can say that glibly because I happen to have one too, but which really the PhD stands for phenomenally dumb, because sometimes people who have the differential equations all over the blackboard sometimes lose the pragmatics of reality. Clearly, the idea that this concept that Behe is so eloquently developed, called irreducible complexity, lies at the heart of any machine, any mechanic. And then when you come across something like the cell, which is probably more complex, if you can imagine the city of Los Angeles as an automated factory, you probably have an inadequate model of what's in the so-called, that's the other fiction that all this has been built on, is the concept of a simple cell. It doesn't exist. This is Michael Denton in his book, I think, first made that clear to me. I guess the fact that the simplest cell we can conceive is far more complex than anything we can imagine.
Mm-hmm. Well, in Behe's not discovery, but his insight is that there are all kinds of systems and subsystems within biology that have this property of irreducible complexity.
And then he picks this
little motor, which is really a fascinating thing. Because
describe that for our listeners.
On the back of a very simple bacterial cell, there is a motor called a motor driving a little whip-like tail, or a propeller called a flagellum. And the motor is made of some 40 separate protein parts, and it includes things like O-rings, bushings, drive shafts, rotors, stators. I mean, these, mechanically speaking, are completely analogous to the kinds of things you'd find in a rotary motor made by Mazda. And experimentally, we know that if you remove any one of these 40 protein parts, the motor simply ceases to function. You don't get 39/40ths the mobility, you have a broken motor. And the reason this is so significant is that the Darwinian model attempts to explain complex things through a series of step-by-step gradual incremental changes. And the mechanism of Darwinism, natural selection, selects for functional advantage. But unless you have all 40 of the protein parts, you get no functional advantage. And so Behe shows...
You can't have natural selection until there's something to select.
Until there's something to select, something functional to select. Mm-hmm. And so what that means is that natural selection will give you no help in building this complex machine. And yet when you look at the complexity of the individual proteins involved, let alone the 40 acting in close coordination, there's no way this could have happened by chance. So if it's not chance and it's not natural selection, what is it? Behe says it looks designed, it is designed.
If it looks like it does,
it's designed, yeah.
Right. Exactly. Okay. There's another thing, though, that go one step further. Let me try to set the stage for my question, if I can, a little bit. If we, just in our mind's eye, imagine looking through a microscope, we have a single cell, just one single cell. And in so many seconds, it will divide into two. Mitosis takes place, and it now becomes two identical cells. They are identical, right?
Initially.
Yeah. Okay. And then they split again. And now we have 4, then 8, then 16. And this process continues to a point when, after which, as we watch more closely, we begin to realize that the mitosis process is starting to have differentiation. Some of these cells start to become different kinds of tissues, bone or cortical tissue or whatever. I'm not skilled enough to make a whole list of the different kinds of tissues, but these tissues then become organs of different kinds, very dissimilar. Now, what puzzles me about the process is that, and I'll use to draw an analogy, is let's assume I had 60 or 70 people, each of which was fully capable of playing any instrument in the orchestra. Let's assume I also had, laying around the room, all kinds of instruments. If I hand each one of these persons a complete copy of the orchestration of a whole symphony, I don't have a symphony, because obviously somebody has to step up and say, start appointing roles and missions. You're going to be first violin. You're going to be percussion. You're going to be woodwind, whatever. And then he's not through. It's got to be very carefully orchestrated. There's a concept, the analogy I'm thinking of is in a design team, like in a computer, there's a function called conflict resolution logic. There has to be a referee, a tiebreaker, if you will. And what's puzzling is I find it hard to even conceptualize a tiebreaker being in that first cell, because the minute that cell splits in two, we now have 2 tiebreakers, and then 3, and then 4. I mean, then we have 4, and then 8. So part of the problem, I'm coming at this not rigorously from an information science point of view or mathematical point of view, and yet my instincts tell me that this process, as we observe it, appears to be the beneficiary of an external information input. namely coordination. And I don't see how it can be self-coordinating. Let me put it in sociological terms. Let's talk about a consensus kind of thing. That's our culture. I long ago did a careful study of the optimum size of a committee. It's 7/10 of a member. In other words, to get things done, someone has to be in charge. And what puzzles me is we don't see a cell somehow spawning daughters and somehow staying in charge, or we don't see a cell spawning off its successor leader. We don't see, there's no visible evidence throughout the entire complication of a leadership, refereeing, these. You can make a list of these kinds of functions. And so talk to me about that in biological terms.
Well, what you're describing is there's a hierarchical logic of organization that's expressed in a cell. The DNA, as fascinating and I think as full of evidence of design as it is, we didn't really mention, but Bill Gates says the DNA is like a software program, only much more complex than any we've been able to devise. If you have a program, that implies a programmer. So I've focused a lot of my energies arguing that case, but nevertheless, DNA is not the whole show. DNA just codes for proteins. And the question then is, how do the proteins get assorted to make larger structures? And how do the cells, the different cell types, what you're noticing is that every single cell has the same DNA in it. So how is it the different cells are differentiated? And how do those different cell types get organized along into new body plans?
Is it possible that the DNA coding structure is only understood in the sense of a first order equation? Is it possible that there might be overlaid or implied metacodes or macrocodes on top of that, so that the total architecture is also encrypted in the DNA?
It's possible. People really don't know in biology. And I have some friends who work in developmental biology, and they tell me that if people tell you that they do know, then they don't know. That it's one of those. But a big part of the mystery appears to be involved in the subdiscipline of biology known as developmental biology and embryology. That we know that the DNA codes for proteins, but proteins, though they're complex molecules themselves, are kind of like building blocks. The analogy is often drawn to a housing construction site where you have your drywall and your wiring and your bricks and your mortar, and those are the building blocks. But the building blocks don't determine their own arrangement. They don't determine the floor plan for the house or the layout of the subdivision. That there's some kind of a hierarchical, some higher order information that's responsible for that, and that really is a mystery as to where that resides. Some people are looking for it in the cytoskeleton. Some people are looking for it in developmental programs, as they're called. But it's an area of active research, and what we do know is that DNA doesn't control everything. Now, that itself raises another profound problem for
how do we know that, by the way?
Darwinism. Well, we'll give you a concrete example. The cell has an architecture. It's called the cytoskeleton, and the cytoskeleton is made of things called microtubules, and they're made of little protein subunits. And every protein,
are they all identical?
They're all identical, and so they're like building blocks. And so the proteins don't determine the structure of the skeleton, the cytoskeleton. They're just the subunits that make it up. So where does the information come from that organizes the skeleton, the cytoskeleton, that in turn governs all kinds of important things about how cells divide and how embryos develop and that sort of thing? We don't really know. But if you think about, say, a building site, the analogy back to a housing construction site, if you've got all your you've got your bricks. The bricks are important, but they don't determine the floor plan. And to then bring that analogy back to biology, if you think about the Darwinian explanation for how you build new body plans, new large-scale structures, getting a trilobite out of a single-celled organism, or something even simpler. That trilobite has 2 eyes and it's got 3 lobes in its body. How does that new structure come about? Well, not just from the individual proteins. They're organized into organs. Those organs are arranged into a larger body plan. And so what that says is that the Darwinian mechanism of mutating DNA will only affect proteins. It won't affect the higher order organization that organizes the proteins, which is required to build a new animal. And that's really the profound problem that's being faced by the Darwinists when they look at things like what's something called the Cambrian explosion in the history of life, where you suddenly have lots of new animals come suddenly into the fossil record. How did you get all this new body plans just from mutating DNA? It doesn't seem to be a sufficient cause at all.
Well, see, I still have a whole difficulty with this kind of thing, because if I'm willing to infer design, you see, I sort of visualize, let's assume I'm a space traveler and I land on this planet. And as I land there, I see a very complex city being built. I see all kinds of structures. I see thoroughfares. I see a pattern to the design and so forth. That would tell me, first of all, that in that city, I've got cognitive behavior going on. There's a mind there, probably more than one, but there's clearly someone quarterbacking it. So as I watch, I'm troubled because as I watch the cell, the single cell mitosis, through mitosis become 2 and then 4 and so forth. Then I see this thing start to take much more increasingly complex shape. I see increasing differentiation. As an information scientist, if I could presume to use that role in the moment, I would have to conclude that that there either is a cognitive engine of some kind inside the process, but if that were true, then I wouldn't expect to see the similarity in architecture between you and I. In fact, I'm probably puzzled as much by our asymmetry as our symmetry. Yeah, we got 5 fingers on each hand, 2 hands, 2 legs, so forth. Our body is very symmetrical, and yet inside it's not. You know, we have one heart, and the internal picture of the human system is very asymmetrical, and so forth. And so, you know, I see, you know, I find it hard to visualize how that's all encoded in the first place. And if it was encoded, I can't visualize it being encoded homogeneously, that all the cells carry all the plans. You follow me?
Right.
That's where I'm so it's from all of this that I come to the inference, can't prove it in any kind of rigorous way, the inference that this entire process is controlled by an external input. And, you know, putting it in biblical terms, I find it hard to escape the view that God somehow is involved in every cell division. And I can look at, I can find scripture that would pretend to support my view, where he says the very hairs on your head are numbered. All of this somehow was stimulated or set forth and so forth before the foundation of the world. You know, the whole distinctiveness of God's involvement here is from outside the time domain in the first place. So as I look at all of that, you know, that gets into holography and a lot of other things that we don't want to get into here on this little excursion. But I guess the key point is we've been talking about the origin of life, and the DNA, of course, on the one hand, in my mind, has put the final nails in Darwin's coffin as far as a viable explanation of the origin of the species, origin of life, on the one hand. At the same time, continues to raise perplexing questions far beyond just our understanding the specific. I recognize the Genome Project and trying to really decode it and so forth. I have a suspicion, even just taking the DNA alone, that they're only at the first level of understanding, that the really disturbing shock is perhaps yet around the corner, to discover that that's just first level of a higher level, you know, a multi-level code.
Yeah, I think what Michael Denton described this to me one time as wheels within wheels within wheels of complexity.
Sounds like Ezekiel 10, but
yeah, it is. It's a pretty amazing description. But there's no question that there's other information involved in building an animal, you know, other than just what's in DNA, and where that resides and how it's expressed is really a profound mystery. So life is Michael Denton likened this one time. He made a distinction that goes back to the philosopher Kant between an organic and a mechanical unity. He said in a mechanical unity, all the parts are fixed, and you can kind of sort of map it out, and you can design it from the bottom up. And once you fix the parts, you can predict the function. But he said in an organic unity, every part is both cause and effect of some other part, and so the complexity becomes beyond computation.
Sounds like a family, but go ahead.
yeah, right. And so there's something profoundly mysterious about life, that he said it defies computation, and that it's a level of complexity, he said, that is of an absolutely transcendent kind. And there's something, there's some parts of the cell that we understand very well, and we understand what they do as subsystems. But the cell is a functionally integrated whole, where individual subsystems, which are themselves quite complex, are quite complex, are interacting with other subsystems, and there's this whole hierarchical logic that you were talking about that just, I think it's almost inexhaustible in terms of its potential for study and mystery.
Well, there's another sort of fundamental point that we sort of skipped over here, and that is this whole argument that deals with self-organization. There are people that somehow throw these words out as if the entropy laws are somehow suspended, and I've never followed them, never had much ability to understand the flow of logic. My first question, I guess, is it a valid observation to argue that things can self-organize? I
think there are some things that self-organize. If you pull the plug on the bathtub, the force of gravity will create a spiral, and we get tornadoes, and crystals organize spontaneously. But they
derive from their intrinsic properties.
Exactly, and they produce a redundant pattern, a symmetric order.
The very fact that they're predictable argues against them being organized.
So there was a scientist, Prigogine, who worked on these self-organizational patterns, and he showed that systems that are driven far from equilibrium, if you put a lot of energy into a system, you can create a symmetrical, highly ordered, highly redundant pattern. But that's not the same thing as information. It's not the same thing that you have to explain in biology.
It is opposed to information.
It's opposed to it, in fact, exactly.
Yeah, because it is predictable, it is ordered.
Right.
That's why, for example, even Carl Sagan resorts in his novel, Contact, to a series of prime numbers as evidence of intelligence. Because if they're totally random, it's noise, and if it's totally periodic, it could have natural causes. A string of prime numbers is something that is regarded, at least, as defying a natural origin. Mm-hmm. And it's probably one of the simplest idioms of this, and it's ironic that maybe it's based sort of Sagan's mantra was the cosmos is all there is, never was kind of thing on the one hand. On the other hand, he himself, in effect, tacitly gives evidence to the role of information as betraying intelligence.
Yeah, he recognizes the connection exactly between intelligence and information. He also vividly illustrates what Dembski's idea of the design inference, or the explanatory filter. With that prime number sequence, you have a very improbable sequence of zeros and ones. And that tips you off that you might have design, but what cinches the case is that pattern of zeros and one matches what Dembski calls an independently given pattern, namely the prime number sequence. Mm-hmm. So what Dembski's theory of design is that when you have something that's very improbable and it matches an independently given pattern, which he calls a specification, that's what triggers an inference to design. A good example might be another good example might be Mount Rushmore. There you have a very irregular shape in the face of the rock, which is highly improbable. But the shapes right next to Mount Rushmore, the natural mountainside, are also very improbable. What triggers the inference to the intelligent design that went into carving the face of the presidents is that we also have a pattern that we can match to something we know independently from the textbooks or the paintings of the presidents. So we've got an improbable rock face, but an improbable shape that matches an independently given pattern. And those two things together trigger that awareness that an intelligence is behind what we see.
So I feel like the astronaut that landed on Mars, and there in the dust, I find a wristwatch. I find Pally's watch.
Yes, exactly. Exactly. Yeah.
Another fundamental point, the argument advanced by our critics saying that we're really building an argument from ignorance, God of the gaps, as they say. Can you touch on that?
Yeah, we hear this all the time, but the idea is that, well, because science hasn't discovered or explained the origin of life, then we're just giving up and resorting to God as an explanation to fill the gap in our knowledge or to fill our ignorance. But when we infer design from the information in DNA, for example, we're not inferring design based on what we don't know, but rather on what we do know. We do know, based on our repeated experience, that information is always the result of intelligence. And we have lots of experience of that, whether we're looking, again, at hieroglyphic inscriptions or computer codes or
Rosetta Stone
or English text. Whenever we see information and we know the causal story about how that information arose, invariably an intelligence was involved in the story, and intelligence was part of the explanation. So when we see information in the DNA and we don't get the chance to observe its actual origin, we can infer based on the same kind of reasoning we use in the sciences all the time, that intelligence was responsible. So this is not an inference from our ignorance, but rather it's an inference based on our knowledge of the distinctive hallmarks or features of intelligent design, namely information.
We can carry the same logic another step. Just as we will identify a participant in a crime by his fingerprint on a gun, just as we can identify someone entering a super secret work project by a retinal scan or some other biometric technique identifying the person. It's interesting. I happen to be a ham radio operator, and you'd think Morse code is Morse code,
right?
But there are guys who use CW or Morse code, rather than voice, when the hams still like to deal with dots and dashes, if you will. It's interesting that even in the dots and dashes, they can often recognize who their friend is because he has what they call a distinctive fist. It's analogous would be to a person's handwriting,
right?
This sort of thing.
Trademark, or yeah.
Well, one of the things that intrigued me when I was studying the Bible codes, when people speak Bible codes, they usually mean the equidistant letter sequence things, which are just one example. The codes are too provocative to ignore, despite the critics. On the other hand, and yet many people misuse them and they don't understand them because it's really, you have to go at this from a cryptographic point of view. But what fascinated me is even the DNA, the RNA, is that it even operates on an equidistant letter paradigm. And that fascinated me. It's the same kind of architecture in a sense there. But we were talking earlier, I think it was Dean Kenyon that made, as he came to his conversion, was fascinated with the first 3 verses of John, that one of the highest titles of the creator of the universe who became man was the Logos, the Word. It's interesting that God, who obviously is very jealous of his name, there's one thing he even puts higher than his name, and that's his Word. We find that in the Psalm, I think it's 138 verse 2. Or 32 verse 8. Anyway, it's in there. One of the things that absolutely fascinates me, just as we can look at the DNA, and if one is objective, you quickly recognize that not only is it subject of design, but it's very skillful design. It's such skillful design we have yet to even understand it. And it's interesting to me that I find the Bible the same way. Because on the one hand, if you just skim it superficially, it looks like a collection of cultural traditions and so forth. And yet, as we study it more carefully, we discover the very text bears evidence of integrated design. 66 books penned by 40 different guys over thousands of years, yet it has integrated design on the one hand. And the thing that that's why I get so fascinated with people like Dr. Ivan Panin, who discovered the first 11 verses of Matthew, the genealogy of Christ, has mathematical properties that you would be hard-pressed to simulate from fiction using a computer. And there's a great debate about the last 12 verses of Mark, for an example, because of certain textual things I won't go into here. Some of the more so-called modern critics have suggested those 12 verses were added later and so forth. Well, when you study those 12 verses in terms of their mathematical properties, you have a heptadic structure that goes down. There are more than 75 features in those 12 verses that have an exact heptadic multiple. If you try to simulate that, and trying to do it in Greek, which is a highly rigorous, very declined language, is 5 elements for each verse and all that, you have a rigid structure you're trying to operate within, yet we find the author was able to preserve without demeaning his meaning, his communication, to maintain a structure that if you used computer, I think we did just to do 35 of those features, you'd have over 1 million supercomputers working over 1 million years to do. I have forgotten the arithmetic. We did it in our briefing package called How We Got Our Bible. But the point is, what's amazing to me, just as we look at the DNA and get confronted with the irrefutable evidence that it is the product of highly, in fact, incredibly skillful design on the one hand, what's interesting to me, we have the same thing true of the Bible. It's changing subject, sort of, and yet I'm not. Here we have a collection of books, writings collected over thousands of years that we now recognize had been guided supernaturally in such a way as to defy simulation on the one hand, and yet it bears the fingerprint, the evidence of the same designer that designed us in the first place. And the positive, exciting thing, to someone who has an open mind and can examine the discoveries of biology, not from the traditions and presuppositions of the past, but with the fresh new young people like yourself that are coming up in that. So I can remember when I was even in high school. I graduated in 1951 from high school. We had biology teachers who preached to us that the greatest need in biology was fresh, new thinkers. I didn't recognize at the time, but they were saying about as much as they dared for us to challenge the presumptions that particular field of study was based on. And so I think it's an exciting trend to see that, exciting trend for science's own sake, to see some really careful thought being given and re-examination to these presuppositions.
You gave that, or mentioned the biblical idiom of the Word. Jesus is also referred in 1 John as the Word of life, and I think that's interesting that the Creator would be referred to as the Word. In 19th century science, the view was that matter and energy were the two fundamental entities, and now at the beginning of this millennium, we realize that there's a third fundamental entity, and that's information, and that's more fundamental than the other two. It's not just having the physical stuff; it's arranging them according to a functional design.
It's even worse than that, Steve, because the quantum physicists now have raised questions whether matter and energy, even length, mass, time itself exist. We discover now they're digital. That's why they call it quantum physics. And there's a unit of length or mass or time that gets to where it's no longer divisible at all, which if you divide it, loses locality. And now the Bell inequality was confirmed by Alan Aspect and his colleagues in Paris, that every photon in the universe is immediately interconnected, and that shatters our Einsteinian views of
my colleague at Discovery Institute, George Gilder, says that the heart of matter is a mystery.
Yeah,
and it's
we're all. My premise is that we're all in the digital simulation. And I think David Bohm and others who have embraced the possibility that even the holography represents a better model of the universe than discrete particles that we tend to take for granted. But that's really a Cracker Barrel time for another occasion. And I really want to thank you for taking your time. I appreciate the presentation that you gave our people on that other tape, and I appreciate the chance to sit with you and sort of go over some of these things in a little more relaxed, interactive way. I'm delighted with your proximity, not just emotionally, but also geographically, to our ministry, and I appreciate your being part of our activities here, and look forward to doing some more of these.